We start chapter 16 with the idea here of an exception. Now, this starts on page 990. Yeah, I'm right. And the the 16.1 carries on for quite some time, but really we're going to break it up into two pieces. First, we're going to look here at just the idea of exceptions and the try catch block, and then the second portion is going to be to take a look at actually handling an exception and getting something out of the caught or uncaught errors that invariably a program, if running long enough, is going to encounter. So an exception is just essentially sort of like a flag. We can use it that way anyway, where it just signals that a problem had been encountered. Now, you can use it that way and just go, something went wrong. And that's not necessarily the best programming practice, because if something goes wrong and you don't do anything about it and you don't terminate the runtime, we can have pretty substantial consequences that come about as a result of that. So it's actually being able to recover from an error that really, creates a less fragile environment that your program is running in. So we have done this all the time, frankly, with if-else, and we have been successful in moderating some of the errors we know that we're going to encounter. So the big example that we have here, at least at the beginning of 16.1, is the idea of a divide by zero. So we know that we can't have the denominator be zero in an equation, because what that's going to lead to is a divide by zero fault, and we can't have that. So we have been building these little if-else chains into our programs where that piece of math is liable to make itself heard, right? So we have if denominator equals 0, and here's your else, because we know that error we cannot divide by 0. So that is the kind of rudimentary error correction that we have been doing to date. We could also build this into a while loop, so that as long as the user continues to incorrectly enter a 0 as the denominator, we will request from them, cannot divide by 0, please enter a number greater than 0. Cannot divide by 0, please enter a number greater than 0. And it will loop until they get it through their thick skull that you cannot divide by 0. And that's fine, and that's good, and it works. And very often that is, in fact, what you will do to, limit the probability of actually creating an error. But that's not always going to be enough. So we have here the idea of an exception. And with an exception, it is either a value or it's even an object. And we're going to see that with the second portion here, the next video. An object that signals an error has been encountered, because that object actually allows us to get to what the root cause of the error was after the runtime has concluded. Because remember, once runtime is concluded, you're not getting any of that data back out. So the idea of throwing an exception is like throwing your hand up and saying, yo, something is wrong. And so throw is the key word that we are going to use there, and throw followed by any statement is okay. So we can have, in quotes here, error cannot divide by 0, and that is going to appear in your output window. And we will see just a really shallow example of this when we get to the code samples later on. But nothing actually comes from that. We just say cannot divide by 0, and once the exception is thrown, we go to the end of, and they've separated this from me pretty substantially. once we get to where that exception is thrown, we actually just go to the return 0 statement after that. And that's not necessarily, and sorry for page numbers, this is 992, and that's not necessarily what we want to do, right? If we know this is going to cause an error, if we know that it's going to throw that error, and if we know that a thrown error with no, what is we're going to see next, which is this try catch block, is going to end your program, that's not particularly good enough. We had it within our power to be able to do something about that. So the nomenclature we have here, and for anybody who's taken Java, this is going to look familiar. We have the try catch block. So the try is the first thing that C++ is going to try to do. In the case that no exception is encountered, then flow of control comes back down to here in our cout statement. However, if the try encounters an issue, we are going to go here to the catch block. The catch block is going to potentially enable us to do something like recover from our issue. So let's come up here and just take a look at what that's going to look like. And I know we did have the very same piece of code down there, but I just wanted to talk about it like this first. So here inside of the try block, this is where we would throw our exception. And in the case that an exception is thrown, the very next statement is the catch block. We can have multiple different catch blocks. The way that works is the first catch is the next call after our throw is encountered. And because these are the try catch are linked as far as keywords go, if I have 15 catches that I'm willing to try and do in order to recover from an error, and let's say the third one happens to work, the remaining 12 are ignored and flow of control goes to whatever the line is after the last catch block. So that's the way that would look. So here we have a try catch block where we can see an exception string is being outputted, and that exception string would say something like cannot divide by 0. And actually you can see that here in program 16-1. I'm actually going to let you go through this and take a look, because we are going to see in our next video what we can do to more adeptly recover from a thrown exception, and that is what we're going to see in the code sample too, is a try catch block that recovers you from an error as opposed to simply reports it. But I'm happy enough to let you look at what can you do when you simply report it out.